when you're on this final. You're given the formula. It's a matter of plugging in numbers. But you have to know a couple little things, okay? When we say H3O, that's the hydronium ion. Okay, it's a big name, but here's what it means. It means this. It means the hydrogen ion. All right? The reason they use hydronium ion there is because when those hydrogen ions get to floating around in the water, they just gang up into H3O. That's how they exist in water. But for you and me, for the normal person, hydronium ion concentration is just the concentration of the hydrogen ions. That's all it is. Okay? So now, let's do this problem. What is the pH of a 0.5 molar solution of nitric acid? Okay? Now, you have one hydrogen here. Okay? So if you have one hydrogen ion there. So if you have 0.5 mole solution of an acid that contains one hydrogen, that means you have 0.5 moles of hydrogen ion floating around. Alright, so all you do is you take that number, so you say pH equals the negative log of this hydronium or hydrogen ion concentration, which would be 0.5 moles or molar. Okay, so in your calculator, this is what you do. You take 0.5 and you hit your log button. And notice that the log button says negative 0.3. Okay, so negative 0.3. So your pH is going to be 0.3, because a negative times a negative gives you a positive. That's the only reason this negative here is here, because of that. Okay, now let's give you an example of something where you have two hydrogens, like sulfuric acid. Let's do the same thing. Let's say, what is the pH of 0.5 molar solution of H2SO4? Notice in this case, for 1 mole of H2SO4, we have 2 moles of hydrogens. Do you see that? So now we have to say 2 times 0.5 means that we've got 1 molar hydrogen ions, 1 mole of hydrogen ions floating around in there. All right, 1 mole of hydrogen ions floating around in there. Because for every mole of H2SO4, there are 2 moles of this hydrogen. Okay, so we have to say 2 times that 0.5. So we plug that in, so the pH equals the negative log of 1 mole of your hydrogen ions floating around. So you would say 1, hit your log button, and you get a 0. Okay, so this pH of that solution is pretty low. You'd say 0. Okay, now I have a feeling that it's not going to be a super complicated process, and I have a feeling that you're just going to be dealing with something where you've got one hydrogen connected to your anion there. Okay? So let's go through the steps again. You've got 1 mole of hydrogen with this nitric acid. So 0.5 times that 1 hydrogen that's floating around there means that you're going to have 0.5 moles per liter of this hydrogen floating around. Okay? So you put the 0.5 in there, and you hit 0.5, you hit that log button, and that gives you a negative 0.3. You turn that into a positive, your pH is 0.3. Let's do one more example. Let's say you've got something like 0.005 molar solution of nitric acid. Again, for every mole of nitric acid, you've got one of these hydrogens floating around. So we'd say 1 times that 0.005. Okay, so 0.005 is what you would use in your brackets. So your pH equals the negative log of that. Okay, so 0.005, hit your log button, and you get a negative 2.3. So your pH, 2 negatives make a positive, is 2.3. So remember, don't freak out. All you're doing is just plugging in your numbers.